easy quizzes. Like I said, those are the ones. Now I got to show math. I don't think you guys are understanding how to do well in this class. Yes, it's about studying every day, but if you get a 40 on a quiz, something that's really hard, if you study or you know, if you can get an 80 on a quiz, not even 100, you can get an 80 on a quiz, that's gonna pass. You get a passing grade. If you get 100, then it goes up even more than that. And again, if you can do, I'm hoping you do better than a 40, but like worst case scenario between two quizzes, one's really, really hard, like impossible. Like I'm just never gonna get above a 40. That's fine. You can make it up if you do well on an easy quiz. We're not taking advantage of the easy quiz. And I'm telling you, this one's easy. Put time into it. Go to G2, practice these. You can all get this one. There's some, I'm not just gonna be direct, honest. There's some quizzes that you're going to struggle. It's tough material. It's tough to teach. It's tough to pick up. Proofs was an example. Proofs was tough. That's like everything you've ever learned in math, all on one quiz. You got to recall, although we focused on a few individual ones. But this is one of these. This is one that you can get an 80 or a 100 on everybody. You got to practice. Like it's not just going to be, oh, I did a couple problems in class and now I'm going to get an 80. That's not going to happen with any of the quizzes. So take advantage of this one. You'll go to G2 ahead of time. Remember, you're going to be forced to go to G2, and I will grade this one because it's easy. I will grade it like a little tougher. If you don't do well on it, I'm going to make you go to G2, which means you're going to probably be getting a 40 on it. Anyway, so now I'm done preaching. This is an equilateral triangle. All the sides are congruent. Says that. That's how we know it's an equilateral triangle. They're never going to tell you, here's an equal, well, I should think that. They're almost never going to say, here's an equilateral triangle. They're going to do something like that, and they're just going to give you markings. Or they're going to give you markings in just the angles. If you see that all three sides are congruent, you have to understand all three angles are congruent. That's automatic. There's no exception to that. All three sides are congruent. All three angles are congruent. If it's the other way around and they give you a triangle and they tell you all three angles are congruent, you have to automatically understand that all three sides have to be congruent. It goes both ways. All right, so with that in mind, what did we say is true? If we know all three angles are congruent, we know all three interior angles add up to, so what do we know each individual angle has to be? Got to be 60, right? So we could do one of two things. We said, well, we could write 4x plus 8. Is that not working? It's still weird. Technical difficulties. Where's the light? Where's the light? Oh, that one was red?
The erasers.
No, eraser I put, because it, oh, there we go. Holy cow, that was just weird. It's like ghost in the machine.
Yeah, without me technical difficulty.
Yeah, I was thinking or something. So we could do this and say, well, if I know all the angles are congruent, then I know every angle. Oh, technically we should do that. Every angle is 4x plus 8. We could now say, if I know all three angles added together is 180, 4x plus 8 plus 4x plus 8 plus 4x plus 8 equals 180. All three angles added together has to be 180. We could do that. But again, the more you understand, the quicker you are with the concepts, the less math you'll have to do. If you understand, well, wait a minute, I could do that, but I also know in an equilateral triangle, every angle has to be 60. They have to be the same number. So I could just say 4x plus 8, one angle equals 60. That's a lot easier math. Even if you get the right answer both ways, that one's gonna save you a lot of time. Sometimes time is an issue on the quizzes. Not normally. So again, that's true of an individual angle. That's true of all the angles added together. Both of them give you the same answer. You solve them out, you get the same answer for x either way. Oh, so did anybody do it? What'd you get for the answer? 52 divided by 4. 13. Should have gotten x is 13. Bro, remember, I don't know how I did on the quiz. Once you solve for a variable, what do you need to do? In geometry especially, but in all of math. Well, read the question and see what the question said. This one does just say solve for x, but it might have said, if there were letters around the triangle, it might have said, what's the measure of angle A, or what's the measure of angle B? Oh, speaking of which, we really did not do a very good job on the quiz. On one of the questions, I mean, I gave some people credit depending on how they wrote it. Like I asked, what's the measure of angle in one of the questions? ACB or BCA or AABC, depending on your version. You had no clue what I was talking about. I got that question all day long from people about what does it mean? That's an angle. You just like we named angles before. That's the symbol for angle. It means we start at angle, or we start at point A, we go down to C, and then we go to B. The middle point, the middle letter, the middle point is the vertex. So it's this angle right here. That would mean, what is the measure of that angle? What is that right there? What's that measure? Again, we really struggled on that one. A lot of people just said, I don't know, or question mark. You guys were able to solve for X. That was part of the problem, but that wasn't the final answer. So a lot of people didn't know how to do a final answer, which cost them a letter grade at least. So yeah, again, that's how you name an angle. Middle letter is the corner, basically the angle. Sometimes there might be multiple angles coming off of it. Like here, you could just call that angle C also. But if there would have been like, if this line continued out here, and then there was a point D or something out here, now you'd have to use 3 letters because there's 2 angles here. And if I just said C, you wouldn't know which one I was talking about. So that's why we use 3 letters sometimes, and that's the way it was in the picture. You had to use 3 letters to determine which angle I was talking about. So anyway, that was old stuff that we apparently have forgotten. All right, so we're gonna tear some book pages out. So everybody grab a book. Starting piles over there. I'm not even sure which ones for tear. Oh, I forgot my glasses again. We're gonna start at page 315. I think it's 315, 315 or 316. 315 at the point. You go ahead and go to 315. And we will clear out through some of these pages. Some of the, actually, maybe we won't clear. Yeah, maybe, maybe we won't clear it out. I feel like we should tear it out more. All right, we'll just tear out through the end of this module. So you can tear out, I'm going to include the final chapter test because we might do something with that. So go tear out through 340. We should tear out more of it. That we have.
You just said we're about 30.
Yeah, you're, you know, so
This should go.
out there, if they're out there, I want them to get started one of them. So if they go, it's like
340, but you didn't say the first
Let
page.
them be out here for the thing.
350.
Yeah, I mean, some of them know to do that, but. Nah, I get no. Oh, that's like, yeah, for Morgan, Morgan, here's JD. I think is they already have to do that. So yeah, you know them. So yeah, so you'll know them. So yeah, they're again, those are the ones that know to get started, but say, hey, let's get going. What's Gill said to get going? Adam. Yeah.
3:15 to 3:40.
That's back probably. Yeah, through 340. So that's way more than we will probably use. Because the last piece of it is like the overall module test. But sometimes I like the questions in that, so it's not a bad thing for you to go back, even if you don't necessarily do every single problem. You go back and kind of see which ones you can do and try to do those. You never know what am I, oh yeah, so when you're done, put them back over in that corner. I think you guys know that. Just in case. So yeah, so the module, the end of the chapter or the module or whatever you want to call it, they have a whole bunch of questions, typically 20, 30 questions. And a lot of times they have some good questions in there, very similar to what we did. So. So I need to put some openness in there. It's empty. It's empty. Basketball game tonight. The boys play. These are all at home. Basketball game tomorrow night. The girls play. And basketball game Thursday night. And then basketball game Thursday night. The boys play.
You know who made it in for the boys? Basketball.
You know, I don't think they sent a roster out. I know some of the people that play. We got one back there.
I know.
Oh wait, you play on our team, right? Here. No, you said you play. I didn't know.
I know a lot of my friends try to do it. They played basketball before. But they said
Adam,
they
you probably know if you like knew their name. Adam could probably tell you their name. JV starts when? And then varsity, that's 7:45. I saw that on Max Prep. Okay. Yeah, so I'll probably come out like, I typically try to come out and get there for the second half of the JV and then the first half of the varsity. I don't have to go home much time, especially the varsity. All right. So I'm just gonna go back through those pages. We've covered a lot of this stuff. We did isosceles and equilateral. That's what this is on. I'm just gonna give you some examples of problems I think are important. There's another topic, which is another lesson. Oh, did we clear that out? Pour that out. It's the last lesson, I think, in the chapter that we'll kind of finish up with, and I'm only gonna pull one problem out of that. We're not doing anything with proofs, even though I'm gonna go over it a little bit. Just mostly for you and your midterm. That could be important on your midterm potentially. So what's the not in here. Okay. All right, I'll sort of do it anyway. Oh. Triangles in the world. Triangles on the TV. Nope, I don't know where that is. So there's a topic that we cover. Maybe we. Oh, here we go. It is. It is. Yeah, it is. All right, so we'll do that one too. All right, so there'll be one for that. All right, so. Nope, nope, nope. There we go. All right, so again, we're not doing anything with proofs. Again, that may be on the district test, but. Isosceles. So here, that's all the lesson. We've already gone over that. If you know two angles are congruent, what does that tell you in that picture? So it's page, I don't know, 316, maybe. I don't know. What page is that on?
Yeah,
316? Yes. 316. What do we know about that picture? What else do we know? Yeah, if you, again, don't get confused when the triangle is turned different ways, and especially don't get confused when all the sides look the same length. Because I'm telling you right now, that's the way I'm going to draw the triangle. You're not going to be able to just look at the triangle and say, oh, well, yeah, those two sides have to be the ones that are the same length. You're going to have to know based on where the angles are. It's the two sides that are connected to those angles. Like, I don't know how you want to say that. These are called the base angles is the way you call it. And then these are the sides that are adjacent to those base angles. So whatever, however you would say that those are the sides that are related to those angles, use your own words so that you understand it. But you got to know those two things for isosceles triangles. Whether they start by giving you the congruence marks on the side or in the angles, doesn't matter. No matter what, that's all congruent. All right, so like next to touching side by side. So two angles that are adjacent, like these. So if we remember how we draw our line and we separate it, angle 1 and angle 2 are adjacent. They share a side. If it's angles, then they share a side. It's the technical definition. So angle 1 and angle 2 share this side right here. It's the right side of angle 1, it's the left side of angle 2. Oh, Brickland, crap. I would still go. I'm sure they'll still want you to do that. Yeah. If you're taking it, you won't be back for sure. If you're not taking it, then you can always come back in. One quick thing I will mention. I'm not going to put it on my quiz. I could definitely see it on a midterm. It's more of an SAT, ACT thing, PSAT, which some of you are still taking. Some of you still need to get your requirement, your algebra requirement, which the ACT, SAT, all those can be one of the tests that works. When you have a triangle, a lot of times, one of the things you have to do in order to figure stuff out is they may say, well, that's 10 down here. And then, oh, boy, I'm trying to think of how they do it. It's something like this, basically. You may have to actually draw in a line yourself and split it into two right triangles. Because if I draw this line in and I draw it in perpendicular to make two right angles, now I have two right triangles. That opens up like a lot of options. Because what do we learn about right triangles? One's 90, but what was the big? So we know that these two have to add up to 90. These two angles have to add 90, but what was the other thing? That formula, a squared plus b squared is c squared. So now that we know that, it's going to allow us to potentially solve for things we couldn't have solved for before. So just as a quick side note, that's one of the things you can do in triangles. Like if I would have said, I think of how they, like if they want the area of the triangle, you need the height for area. So maybe they said, this is, I don't know, 19. Well, if that's all they gave you and you don't draw that line in, I don't know what the area is. I don't have the height. But if I understand, I can draw the height in and that makes it a right triangle. Now I can say, and then again, this would only be 5, which we'll get to that down the road. When we draw that line down the middle, it actually splits the base in half. So now you can do something. I'm not going to spend a whole bunch of time on that. We have a lesson coming up in the future. We'll go more into that. But if they have proof stuff on there, that's one of the things that sometimes you have to do in proofs as well, is draw. You have to create that line. There's a word for it. It's called an auxiliary line. It means it wasn't there. You had to draw it in. You had to draw that imaginary line. Let's see. So we're not going to do anything with that. So let's just click over here. All right. So we are going to do something with this. So this is kind of getting also into the next lesson. If they give you, and they've already solved it out, that's why I'm zooming way in. If they give you a triangle on a plane, what'd we say one of the things that you might have to do was? Anytime you see a coordinate plane in a shape, what's one of the things you need to think about? Anytime, so this is, write this note down. Big capital letters. I will be shocked if you don't see coordinate plane stuff on your midterm. Anytime you see a geometric shape, triangle, rectangle, rhombus, pentagon, whatever, on a coordinate plane, which is a graph, an X and a Y axis, you need to think of this immediately. What is it? Because they're not giving me any numbers, right? Distance formula. So write that down. You need to think distance formula. Because which time? I said a lot of stuff. Oh, the whole, so this one. So anytime you see I said geometric shape, you can just say shape. Anytime you see a shape on a graph, like it's called a coordinate plane is what I said, but it's a graph. It's got an X and a Y axis. That just means you can calculate out the distance. You can figure out how long the sides are. So it might be that you're proving triangles congruent. Because if you can prove all three sides are the same length, like side, then you can say they're congruent triangles. Well, you can do that. You can solve and figure out what is the distance between those 2 points using that distance formula. And then if you can figure out the length of all 3 sides, then you'd have to do that for 2 different triangles. If all 3 sides are congruent across both triangles, then they're congruent triangles, side. Now in this one, they're determining whether or not it's an isosceles triangle. So what would we need to do to determine isosceles triangle? We don't know anything about angles, so it didn't tell us that 2 angles are congruent, so we can't say, oh yeah, it's isosceles, the 2 angles are congruent. So what's the only other way to tell if a triangle is isosceles?
On the other.
Yeah, we don't know if it's an isosceles to find them. We only have one. We know that the 3 angles added up would be 180, but we don't know anything else at this point. So what's the other way to prove a triangle is isosceles? Or what's the other thing that's true about an isosceles triangle? No, but we're going to use that, but that's like an isosceles triangle doesn't have to have a right angle.
It has to be 180.
Well, all 3 angles, well, you're thinking about the wrong part of the triangle. Yeah, if it's isosceles, 2 sides have to be the same length, right? So we need to figure out how long are the sides and see if 2 of them are the same length, at least 2 of them. If it's 3 of them, then it's equilateral triangle. Is it possible this is an equilateral triangle? It could be an equilateral triangle. Why not? Yeah, this is 70 degrees. If it was equilateral, every angle has to be 60. So it can't be equilateral. Like there's no exception to that. Every equilateral triangle, if all 3 sides are equal, all 3 angles are 60 degrees. So it can't be equilateral. So we would need to plug in. I guess I'll just write it out here. So this would be 1, 2, 3, 4. -4, -2 is one point we would need to use. Point A would be what? 0, 1, 2, 3. See it? So that would solve for the distance here. So again, you'd plug it into that formula. Then you would have to do that same thing with B, 1, 2, 3, 4, 1, 2. Now, short version is, if these are the same numbers, they're just kind of like flipped, then it's definitely going to be an isosceles triangle. Oh, I'm sorry, -2. Yeah, because it's down. Yeah. So if you can visually see it, now you'd still have to show the math for me, But if you can just see, well, this side is the same length, like if I split that, remember I said if you draw a line down the middle from the vertex, the top point of the triangle, if you're creating equal length sides, so this is where the right triangle does kind of come into play a little bit. If you're creating an equal length, if this is 4 and this is 4, right? Well, I know that this has to be the same length, right? I don't know what it is, but it's a shared side. It's the right, so this blue line is the right side of this left triangle. It's the left side of this right triangle. It's got to be the same length, right? It's congruent to itself. And I know these are both 90, right? So what do I have? Well, I have two congruent triangles. Angle side, I'm sorry, side, angle, side. So both of those triangles are congruent, which means if the triangles are congruent, those sides have to be congruent. So you can kind of figure it out sometimes without even doing math. If you think about how do I prove triangles are congruent. So again, on a coordinate plane, the first thing you think is distance formula, but still, like if you remembered those concepts about congruent triangles, a lot of times you can use that and you can just kind of prove to yourself, which means you would maybe be able to skip some of the math that you would normally have to do. Also, if they're right triangles, instead of using the distance formula, if I know this is 4, right? I can just count how long this is. 1, 2, so I start here. 1, 2, 3, 4, 5. So I know that's 5. So if I have a right triangle, I can also do the a squared, b squared, c squared thing. Oh, plus. So I could say, well, and it doesn't matter which one is a and b. So I could say 4 squared plus 5 squared equals c squared. C squared will be which side? Like what's c squared is always the left. C is the hypotenuse. You got, again, write that down. You didn't know the answer, which was pretty much all of you. C is always the hypotenuse. Next to that, right, the hypotenuse is always across from the right angle. Got, like that should be automatic with right triangles. Soon as you see a right triangle, soon as you hear a right triangle, you need to think a squared plus b squared is c squared, and you need to be able to identify where c is. C is that side. A and B don't matter because you're going to wind up adding them together anyway. 5 squared plus 4 squared is the same thing as 4 squared plus 5 squared. So it doesn't matter which one of those you label A or B. We said those are called legs. If you remember, A and B are the legs because they're the ones that touch the right angle. So now if I solve that out, what would that be? 16 plus 25. We'd get 40 equals c squared. Does 40 look like it should be the right number? If I got a 4 and a 5, does 40 make sense? Because I mean, if you're on a coordinate plane, here's where you can, this is one of the times where you can rely on the figure. If it's on a coordinate plane, to be drawn to scale. If this is 4 and it's not a good one. If this one is 4 and it's that long, right? So it goes from there to there. That's 4. That distance is 4 on that grid. And you can actually do this with paper. You can mark it on paper and use it to make your best guess if you have to. I mean, that won't work on mine. You guys should work. But on a district test, if it's multiple choice, you can mark it if it's on a coordinate plane. It has to be to scale because all of these have to be the same size. If that's 4, that should be a little longer. Well, yep, sure enough, that's a little longer. So that would be 5. That whole actually, that's almost perfect. That whole pencil is 5. So if I match that pencil up, that's probably about 6. It's not going to be 6 exactly, but it's probably about 6. It's about 1 square longer, probably a little longer than 6 would be my guess. Oh, did I add them wrong? Yeah. I'd like to say that I was just doing a mistake on purpose to get your pay attention, but I was fine. Thank you. So now 40 doesn't make sense. So what is it that we need to do? The last step we said it's the same thing as the last step in the distance formula. And you got to take the square root because it says c squared is 41. Well, the way we get rid of that is to take the square root because we just want to get down to c. Well, then we got to take the square root of 41 on the other side. Square root of 41 is about 6.5 probably. Yeah. So again, when you get a number that's way too big, you got to remember, oh, that's right. I got to take the square root whenever you're doing this a squared, b squared, c squared stuff, or whenever you're doing the distance functions. But that little trick of just measuring if it's multiple choice, it'll get you pretty close. Hopefully you'll know how to do it. All right, so on a coordinate plane, you can rely on it being drawn to scale. You a lot of times will use right triangle stuff because you can always draw in a line that's going along the grid lines. Almost no matter where you are on the coordinate plane, you can do that to some extent. Let's see. Oh, to figure out if it's isosceles, you're gonna have to see how long. Oh, and here's another. If I know that this is 4 and this is 5, I know this is 4 and this is 5, right? I really don't even have to do the math if the question is just, is it isosceles? If these are the two same numbers and I'm solving for that, I'm going to get the same number, right? Like it's this, I'm solving the same equation twice. This is a squared plus b squared equals c squared. Well, this is a squared plus b squared equals c squared. They're the same. It's the same equation. With the same equation, I'm going to get the same number here, which means, yeah, those are congruent. So again, you don't always, depending on what they're asking, have to do the math, because all they really want is they want to know what is the measure of these angles. That's all they really want. I think they even just said angle B. So if I just need to determine if it's isosceles, I could do that without really doing the math. Just by saying, well, this is a 4 and a 5, this is a 4 and a 5. It's going to be the same equation twice, so this is going to be the same number. Now that I know it's isosceles, what would angle be? How would I solve for angle B? Last step. I know it's isosceles, which means I know those two angles are the same. It wants to know angle B. I think that's what it wants to know. This is the same thing we did last class. And this is a very common, although the math will probably be trickier, it's a very common isosceles triangle problem. This is one of the easy problems. So again, I didn't say this was an easy topic. I said it's a topic you can all get if you practice. So you all are going to need to practice this because I'm telling you, this is one you can take advantage of. All the problems are pretty similar. Algebra can be a little more difficult, but the concept is the same every time. What do? I mean, what is one thing that you need, like, what's in the picture that you need to know? We've proved it's isosceles. So first you got to be able to do that. Now, what's in the picture that you use? Look at your pages, you can look at mine, but we've already solved for that. The hypotenuse was this. We solved for the length of those two sides. We got the same number. So we know it is an isosceles triangle. Now we're trying to solve for the measure of angle B. Helen. So how?
So, if we know that the top one is 70 degrees,
That's the thing you need to.
the isosceles, both sides, the other angles have to be the same.
So we know these are the same. That's the key. So again, if you know it is an isosceles triangle, if you solve it out and you know those two sides are the same length, It's the same thing we just did in the pictures. It's just on a grid. If I solve out and I say, yeah, I know those are the same length. I have the congruence marks there. Well, if those are the same length, these have to be the same measure. They have to be whatever that number is. I don't know it, but whatever that number is, it's got to be the same. So I can say my equation, those two angles added together plus 70 equals 180. So when you go through and do the math, you'd get 2x equals 110 because I subtract 70 here to get rid of it, which means I got to subtract 70 here. And then if you divide by 2, whoops, x equals 55. So each angle, angle B and angle C, are both 55 degrees. So there won't be anything easier than that on the quiz. If you're struggling on that, then you got practice to put in before this quiz. I think that might be all we're doing on I mean, we've already covered the general concept of isosceles and equilateral. I'm not going to keep going back over that. I just wanted to do something on the coordinate plane real quick. Tell you what, this will be sort of part of your practice time. Try to do the check problem. So there's two pieces. First, I want you to prove in some way that that is an isosceles triangle. That's the first thing you have to be able to do. It is, I'll just tell you it is. So if you don't know how to prove it, you can skip to the next step and solve for the measure of those angles. But I want you to prove it. You need to be able to figure out how would you prove it? Two ways, we said. What did we say it was? 316? I'm sorry. Yeah. 317? I'm not looking to. So what are the two ways to prove it? If you have coordinate plane, so we need to prove two sides of the same length. So we could figure out now, this one's easy to solve for, right? This side is 1, 2, 3, 4, 5, 6, right? Are those going to be 6? Again, it has to be to scale if it's on a coordinate plane. Are those going to be 6? Yeah, there's no way those are the same length, right? So the only two sides that could be the same length would be these two sides. So I can prove it in two ways. What's one way? So my question is,
X and Y.
hold that thought. So here's my question. Is line XY congruent to line XZ? So I could do what? I could just do the distance. I could just say, okay, well, what's the coordinate point? What's the X and the Y? So -3, 1, 2, 3, 4. So that would be -3, 4. That would be 0, 1, 2, 3, 4, 5, 6, 7. And I could do the distance for. So that's one way. And then I do that twice. I do that for these 2 points. These 2 points, if I get the same number, then yes, they're congruent because those sides are congruent. But what's the other way? If I just need to know whether or not they're congruent. Like they're not asking me to say what the length is. I just need to know whether or not they're congruent. What's the other way? Yeah, I could try to figure out if I can create congruent triangles. So I could say, okay, well, let me draw that. Again, it's called an auxiliary line. I didn't even know that before I read the lesson either. It just means I'm just trying to use a math concept. I'm trying to create two congruent triangles. Well, if I know this is 3 and this is 3 now, which it is 1, 2, 3, 1, 2, 3. So I know one side of that triangle is congruent. I know this side is congruent, right? Yeah, I'm going to get rid of all that. We're going to do it the other way. We already did it one way. So now I'll just show you the other way. If that's 3 and that's 3, they're congruent, right? Well, this side is also 3 and 3. It's part of the same triangle. Actually, I could even really, I guess. Yeah, I don't even really need two. What? I don't even really need 2 marks because that's actually the same size. That's actually 3 also. So all of those are 3. Don't know what that says 1. There. So those are all 3. So they're all the same length. Kind of done. Don't I already have 2 sides that are the same length?
I mean, yeah, but
As soon as you have 2, it doesn't matter. There's no but. Doesn't matter which sides they are. As soon as you, so if these are the same length, then this is an isosceles triangle. These are the same length. This is an isosceles triangle. Now, you would have to understand that makes them congruent. Like if that's a right angle, like that's the other part we said. If that's a right angle, then it's side angle side. So that's what we did before. So that would mean this angle is congruent to this little angle. This angle is congruent to this little angle. They're congruent triangles, so everything's really congruent. So how would you solve for the angles then? Now that we know they're isosceles. So we know, yes, this side has to be congruent to that side because if we drew the line down or if we solved using this formula, we proved that those sides were the same length. So now what do you do to solve for the angles? Angle Z or angle Y, doesn't matter which one. Why they use Y twice.
what do you mean? Why did you use?
Well, they used Y, I mean, they didn't use it, but they had the Y axis and then they called it point Y. That's a little, and they did it with X also, but at least the X is way over there, not next to the X. But again, not a big deal.
But at least you can know which one is the point and which one is in the actual.
How do you know that?
Because the regular Y has a little view and then the other one is just straight down.
Well, plus what's true about a point? How do we name a point? Capital letter, right? So a point is always capital. So that's another thing to look for.
Could you repeat the question?
So we want to solve for the angles. I don't know which one it, I think it says yeah, actually it asks you to solve for both, right? Doesn't it say X, Z, Y and X, Y, Z? Don't
Oh,
have to solve
since
for
we
both.
know that X and Y are the same, X is 90 degrees. Oh, that's a X and Y, and then Y and Z. 90 degrees, so then you can just subtract 90 degrees from 180 and then divide it by 2.
Same equation we just did. I mean, the 90 is different, but that is a very common equation. That needs to be an automatic thing. If you know, I don't really know which angle to call. Well, put it this way. These are the base angles, right? We said the base angles are the ones that are congruent. So if you know the third angle and you don't know the base angles, it's that equation every time. Like if these are both blank, then they're both going to be X or Y or whatever variable you want to use. All you're doing is saying base angle plus base angle, same number, plus whatever the other angle is, adds up to 180. That is a very common problem. Sometimes they'll give you one of the two, and then you have to know to write that in the other angle. So that's the other type of problem. All right. So now go ahead and solve it out. You finish the algebra real quick. While you're doing that, I'll see what the next thing we're gonna do. I'm not gonna do a lot with equilateral. It's same concept, only now we know every angle is 60, so we know a little bit more information. And we know that all the sides are the same length. I will go over this one. This is actually more of a proof than anything else. What did you get for the other one? What was the answer? Got to be 45, right? All right, so on this particular problem, I'm going to do it a little differently than what the book is asking. I see this being the kind of proof you could see on the midterm. I'm not doing anything else with proofs. We don't know this is equilateral. You probably would guess it. but the question would be, prove this is equilateral. What is it that you tell me what we can fill in first? What can you fill in on this problem? There's one thing you know, and then there's a lot of stuff you don't know. You would probably guess it. There's one thing you know. Yeah, keep hearing it. But how do we don't know that yet? There's only one thing we know.
Angle K is 60
How do we know that?
because both sides are 12 feet.
So this is the difference between assuming things and proving things. We know these sides are 12, right? We know they are congruent. So what kind of triangle? For sure. Like right now, this is a what? Right now it's isosceles. We know it's isosceles because we proved, based on the numbers, we proved these two sides are congruent. So if two sides are congruent, you're so happy to be that, that you missed yesterday. You're so happy to be back on that. So we know if those two sides are congruent, what is true about the triangle? Yeah, K has to be congruent to L. That's what we know.
So
Now that we know that, what's the next thing we know?
J is congruent. I mean, not, wait,
Can't say
60
congruent
degrees.
yet. J is what?
60 degrees.
Why do we know that?
Because if all angles are 60 degrees, it has to add up to 180.
It's called like an informal proof. Like we're not really writing the statement and the reason. We're just going through like what we know. So if I know those two are 60, I know all three of them have to add up to 180, right? So if we call that x degrees, x plus 60 plus 60 has to be 180. We know that's absolutely true for every triangle. I can solve that out, and x has to be 60 degrees. Well, now what do I know? Now what do you know? What do you? Well, you have to be able to prove it out. Like I said, well, you can't see it because one could be 59.9 and one could be 60.1. Gotta be able to prove it. Like you guys assumed on one quiz that there was a 90-degree angle in the figure, and there wasn't. And y'all missed that one if you assumed it was 90. Because it looked like it was 90, but it wasn't. So you gotta be careful about looking. Now, if it's on a coordinate plane, you can assume a little bit more because it has to be drawn to scale. Because you have grid lines, you have number lines that have to be like the same distance apart. The numbers have to be the same distance apart. If it's just drawn on a blank page, you can't assume unless you just can't figure anything out. Like if you can't prove anything, but you got to be able to take some kind of a step, then you may have to make an assumption. But in geometry, you've got actually in all of math, you've got to be able to prove something before you can make that next step. So if we know all angles are the same, that means all the sides are the same length. Now we prove that it's an equilateral triangle. Again, you would have probably made that assumption, but sometimes that will get you in trouble too, like you did on that one quiz. All right, so that's all I'm going to do with that. Kind of a similar concept there. If we know those two sides are 5 centimeters, what do we know about that figure? I'm not going to have you guys do it, but we know it's isosceles. So once we know, so which sides are congruent? Two that are 5, right? So if those two are congruent, what else is true? Next step would be, as soon as you see two sides are congruent, your next thought has to be, well, if two sides are congruent, two angles are congruent. Well, now if I know all three angles add up to 180, it'd be back to that other equation, x plus 60 equals 180. Well, then these would both have to be 60 degrees, which means it would have to be equilateral. I'm not going to put anything with that kind of proof stuff on your quiz, but midterm, I thought there'd be a lot of proof stuff on there. Some kids said there wasn't a lot of proof stuff last year, but you know, I never know how accurate sometimes that is. This is a problem that could be on your quiz. I believe I did something like this last year. I don't remember seeing, I looked at the quiz. I don't remember seeing it. Maybe it was on a different quiz. Could wind up being on this one though. What is it that we would need to know to do in this? And again, you could probably guess at it.
Uh,
Do we know what all the angles are? It's just because A is 60 degrees. How do we know one's not 59 and one's not 61? So what is, again, it's,
Don't know that it's some sides are.
so what do we know? Again, start with what you know. And it's a little tricky to see the markings, but we know A is 60, so we know one angle. Do you see the other markings? Some of the markings are a little tricky to see.
Yeah.
I'll draw them in for you with red.
Those two sides are.
So that's what you, if you didn't see those markings. So now that we know that, what do we know? So what other angle is, so what angles are congruent if we know those two markings? Say it again.
Oh,
A and what? A and C. It's always the angles that are at the base or the bottom of those, like. So we would go like, if these are the two sides, you gotta go to the, like the, how it's just, they're called base angles. If you're not visually seeing it, it can't, put it this way, it can't be the angle in between the two. Like if both of these go that way, that's angle is in between the two, it can't be that, it's the other two. The base angles are the other two angles. So this angle is congruent to that angle. Well, we already know one of them 60, so then we know that one has to be 60. Well, if we know two of them are 60, what's the third one gotta be? Gotta be 60 because they have to add up to 180. Now we know it's what kind of triangle. Yeah, so we know all the sides are equal. What's important? What's the other thing important to recognize about the figure? Let's see this. What's the other thing I constantly tell you when figures get a little complex with they're not equations, but I'll call them equations. What with the equations that they're giving you in the figure? Oh, I tell you, there's one thing you got to make sure you make a note of, or that will help you figure out how to set up the equation. There's one important thing to always notice to tell what the figure is talking about, what the expression or equation is talking about.
Wait, so you,
Why is it important? Or talking about the letter line. Oh, yeah, there's something else.
so
Obviously,
you
the
put that
variables
all
are.
the other angles are 60 degrees, right?
So all the angles are 60, but I'm more referring to this one little thing that I'm just reminding you again of it. It's not the A squared. We don't really have a right, when we could make it a right triangle and draw a line down the middle. We don't really need to in this one. It is a math thing, but it's not even a concept. It's just one little thing you have to notice about the numbers or the equations they're giving you.
It's just like about like it takes a place of a number. Like
No. What's important to know whether it's talking about sides or angles?
oh, the degree.
Yeah. This is talking about an angle, right? That's talking about the measure of an angle. Don't think that's about the measure of a side. These are sides. There's no degrees, right? And they're outside the triangle. So that's another clue. If they're outside the triangle, typically they're going to be about the sides. If it's inside the triangle, typically it's going to be about angles. Sometimes, though, it could be outside the triangle and still talk about an angle if they just can't fit the whole equation inside the triangle. That'll happen, or inside the angle. Just remember, degrees tell you it's about angles. No degree tells you it's about the length of a side. I guarantee you some people are gonna mess that up on one of the questions where it's a little trickier to tell what the equation is talking about. Is it talking about a side or is it talking about an angle? All right. So that one you would just say 4y subtract 2 equals 2y plus 2. Because it's equilateral. All the sides have to be equal, so those two have to be equal. How would you solve for the x? So you know the expression that has x in it, 6x plus 6. What would you need to do? What equation? Okay, shut up. Yeah, that's one angle. This is referring to one angle. We know that angle is 60, so 6x plus 6 equals 60. Think that was everything on this lesson. So I'll give you the problems. Boy, not gonna have it. So, I like this problem. You may want to try that on your own. So make a note by that check problem right below. Yeah, so let's see. I'm not assigning a bunch of these are proof problems, so I'm not assigning a bunch of them. I would say number 5 on 319. I'll write these up later, but for now, if you just want to mark them since you're in your pages. So number 5, again, make sure you can prove that it's isosceles or equilateral. Don't just assume it by looking at it. Because this is one lesson where I think I changed the questions up a little bit more to fit what I thought you needed to understand. Let's see. Numbers. So next page, number we need. Oh, me? Yeah. I'm the teacher. Yeah. You know, I haven't seen him in forever. He is in this class, but I haven't seen him in forever. Yeah. Like even before Thanksgiving, a week or two before, I don't think I saw him. All right. So number 6, number 7, again, they're pretty similar, but that's fine. You don't necessarily have to do every problem. Definitely 8 through 13. I think that's probably enough. I mean, these are all these word problems are all good as well. I'm not putting word problems, but the midterm, I would be surprised if there aren't some questions that are about equilateral or isosceles, but they're word problems. They're not just here's your figure solved. So if you want to try, I'm going to go ahead and write up 14 and 15. But I won't be putting them on mine. Remember, the midterm is 20% of your semester grade. That is a huge chunk of your semester grade, though. All right, so that's all of them for that. If you didn't get all that, I'll write it up in a minute. We got to do another lesson. Hold on just a second. What was that? Don't have a midterm like you're exempt today. Probably every class has them. I mean, we literally have a whole schedule. The last week of school is midterms. If there's a class that they're saying they don't have one, that's up to the teacher, but we have to give one in geometry. Yeah. Okay. I'm assuming it just doesn't, I don't know if they put it in as an A or if they somehow don't put it in at all and it just takes your 2 quarters. That you'd have to ask the teacher. I have never ever had a class, even when I taught or even when I teach classes that don't have an EOC. I've always had to give a mid. Sometimes I still had to give a district test as the midterm. Sometimes I just made the midterm up. Either way, though, there was always a midterm. All right, so turn to page whatever this is on. 325. A lot of this is very conceptual, but it is on the quiz. It is definitely on the quiz. I looked at the quiz, like I said. Some of these are a little tricky. Some of you'll think they're easy. It's totally conceptual. There's not a lot of math. I'm going to do it pretty quickly. We might review a couple of things on this. So when you have, again, this is coordinate plane stuff for the most part. Sometimes it's not, like this one's not an actual coordinate plane, but well, yeah, they just don't give you all the grid lines. They don't give you the numbers. Still a coordinate plane. Probably not a good time. Let me do this and you'll still have time. Because this is going to be a quick lesson and it is definitely on the quiz. So when you have a coordinate plane, you're dealing with isosceles triangles. There's some properties that are going to be true. It has to do with drawing that line down the middle, and it basically makes two congruent triangles, right? If we take any isosceles, so you may just want to write this down and memorize it. If you take any isosceles triangle, so we know those two sides are congruent. If you draw a line down the middle, you create two congruent triangles. Automatic, guaranteed. So again, write that down. If you have an isosceles, or it could be equilateral, because again, equilateral would also have two congruent sides. So if you have an isosceles triangle, doesn't matter. That was a horrible job of drawing that line. But that's. I don't know how to get rid of that. There. There we go. So again, I'll draw a better version of that. So if I draw a line straight down, it will always be perpendicular. If the original triangle is isosceles, that will always create two 90-degree angles, because that's the way I would draw it, is perpendicular. Well, that means that automatically, if that's perpendicular, that's 90 degrees. I'm creating two equal segments down there. If I know it's isosceles, I know these angles are congruent also. So it's always, there's multiple ways to prove it. Always going to be two congruent right triangles. So the fact that they're both congruent means that you got a lot of things that are going to need to match up. The length of this is going to need to be the length of this. Obviously, this side will be the same number. Obviously, these sides will be the same number because that's how you know it was isosceles to start with. So if zoom in. So if I give you a figure, if I know that this point is A comma B. Again, they don't give you numbers. It's very conceptual. That gets confusing when there's not numbers for a lot of people. I would know if I drew a line straight down, shoot. If I draw that line straight down, draw just an imaginary line in. What's true about this point right here? There'd be right angles, but what is true about that point, that specific point? It's the angles right here. Like what? Well, I'm just talking about that specific point. This point right here. This point is A comma B. This is point C right here. I don't know why they have the 2A written so far over, but that is kind of confusing. Point C is actually this point over here. So if that's 2A comma 0, and if that's A comma B, what is that point right there? What would the coordinate be? Again, no numbers involved. It's very conceptual. Not AC, but close. Because C is, remember, C is not C is the name of the point. What is the X and Y value for that point? Well, 2A is out here. I want to know what that point is. The red, I'm drawing red. What is the X and Y value of that red point? The Y value should be pretty easy. What's the Y value? Y value is 0, right? I'm on 0 on the Y axis. So the Y value is definitely 0. So it's something comma 0. What's the X value? That's it. It's A, right? It's the same X values up here, right? It is directly in line. I drew a line straight down, perpendicular. So it is A. So there are a few different questions that you're going to see with it's all that same concept. It's just they might not give you A comma B. They might only give you this one. They might only give you this one and not that one. They might put the triangle in different places. Like they might draw the triangle like with the vertex right on the y-axis. They might draw it sideways instead of straight up and down. It's all that same concept of whatever this length is here, it has to be the same as this length. That length is A, right? If this point is A comma 0, that means I'm going a distance of A over. We don't know what A is, but that is the length of that line. A is the length from 0 to that point is a length of A. So that's why it's the X value, A. Well, if I drew that line straight down, that little section there has to be A. That length is also A. That's why we can say this point is 2A, because it's A plus A to get all the way out to the blue point. Well, I'm not going to put a bunch of questions like this on there, but there'll be one. So you got to be able to read a figure with no numbers, completely conceptual. This is the one I said I probably just put one question on it. So there'll probably be one question from a coordinate plane, one question like this, which is a coordinate plane, but there's no, like, the other question will have numbers, and you'll have to do something with the numbers. This one won't have numbers. It'll have zeros, I guess, but I mean, you should be able to figure out at least which number is 0. One of the numbers is pretty much always 0. Because I pull this straight from the book. So you should be able to figure out if a number is 0. If it's on the 0 of the y-axis, then the y is 0. If I put it on the 0 of the x-axis, so if it's here, like, let's say I drew the triangle like that, well, this point, like if I drew the line straight down, that point would be 0, 0. That's an easy one to figure out. This point up here would be 0, comma something. I may not know what that number is, but it'd be 0, comma something. So again, some of them you should just be able to figure out based on the fact that it's a 0. And there's not a ton of them to practice, I don't think, in the practice problems. So you'll have to maybe review the examples that I show you. So that's the concept. Here's an example problem right now. Speaking of which, I don't make you draw anything out. I don't even want to do that. I think I'm going to have you do that. I'm going to let's just look at ones where it's already drawn for you. There, so here's a good one. So there's what I told you, it might be drawn straight down the y-axis, like that might be the center, the top vertex. So they want to know, what are all those question marks? So we can kind of figure some of them out pretty easily. What is the y value here? At 0, right? Again, that's an easy one. This point, so they're talking about the vertexes of the triangle. If you're not understanding where they're even getting that's what they're talking about when they're labeling those R, S, and T. Well, this y value, right? The x value is going to the left. I don't know what that number is. I know it's negative 2a, but I don't go up or down. It's got to be 0. That's got to be 0. You should be able to get that part correct for sure. Again, same thing over here. I don't really know what this x value is as far as a number goes, but I know the number for the y is 0. It's on the x-axis. It's got to be 0. So at least get part of it if you can't figure out the more difficult part. what would have to be true? So again, it is an equilateral triangle, right? I drew a line straight down. What does that mean? I mean, I didn't really draw the line, it's the y-axis. What is true in this? Same thing that was true in the other two examples. What's true? So there's right angles, right? This creates right angles. What else is true? I don't know exactly what you're talking about, but I'm going to jump forward a little bit. They're congruent triangles. This, I wish I should do this in my smart notebook. This triangle here, we proved it several times, so I'm not really going to prove it again, is congruent, I'll do it in red, to this triangle here. They're the same triangle. If I split an isosceles triangle in half down the middle, it creates two congruent triangles. Always. Like if you just want to write that down and memorize it, write it down and memorize it. Not a huge fan of memorizing stuff, but if you take an isosceles triangle and you split it between the two sides that are congruent. So I'm drawing a line straight down between the two sides that are congruent. Again, if it was turned sideways, I draw that line sideways and split the two sides that are congruent. That creates always two congruent triangles. Has to. We proved it out earlier by saying, well, I know this side is congruent to itself. Well, now if I know there's a right angle, I can do a squared, b squared, c squared, and it's going to wind up being the same equation. So that's going to always be the same number. Well, that's side, side, side. Proves two congruent triangles. Again, you can follow that logic even a little bit. You won't have to memorize as much. If you can't, then you just need to write down. If you split an isosceles triangle down the middle in half between the two congruent sides, you create two congruent triangles. Well, that means this here, well, we'll say this green line here has to be congruent to that red line. So what is this x value? Exactly right. Because if I'm going a distance of 2a in the negative direction, I'm still going to go that same distance. It's just going to be a positive number. And whatever you need to memorize, make your own notes and memorize. If you get that concept, then you're pretty good. It doesn't get any more difficult than that on the quiz. It's like at that same level of difficulty, the conceptual question I'll give you. And I think that's the only one I really. You can try to do the check problem on your own. I'm not going to go through that one with you. Some similar concepts. Some of the numbers will be zero. You should be able to figure out which numbers are zero immediately. And then you got to figure out what are the other values. So try to do that check problem. And I think that is it. Hold on. Oh wait, what is that? Triangle? I don't think we're doing anything with that. We might have already done some stuff. That's a more complex version, but same concept. So I would ask you, like maybe what is some of the values? The 1/2, like this b/2 would certainly be a little tricky there. But that doesn't mean I'm not going to do it. It would definitely be trickier. So if you want to look at that example, they're doing some stuff with solving. I'm not super. I don't see it being this complex, but could be a different version of that that's not quite so complex. I do like this one a lot. So the only thing I'm going to mention here. If lines are the same distance apart, they're parallel. That's all I'm going to mention. I'm not going to do it, so I'll just show you quickly. This is more of a midterm type question that I can see the district doing. I would like you to understand, if you can visually see lines are the same distance apart, what is the distance from here to here? From that to that? It's A. So if you don't understand how we got that, if I'm on the y-axis, what is the x value? it's 0. Because again, anywhere on the y-axis, right? Anywhere on this y-axis, what is my x value? I'm at 0, right? So I'm going from 0 to whatever the x value is. Well, the x value is a. So that distance is a. A subtract 0. We said subtraction is what? A subtract 0 is a. So I'm then going a distance of what? If my next x is 2a. How far did I go from to get? So this is point B. This is point D. How far did I go to get from B to D? To the right. C is a point. C is not a x value. So it would be the distance between 2a and a.
Oh,
So I'm going A again, right? You could just say 2a subtract a. Remember, subtraction is linked. You can just subtract them. You could just say, okay, well, my distance is 2a subtract a. Well, what's my, so again, from here to here is a, from here to here is a. What's my distance from there to there? A again, 3a subtract 2a is a. So I'm going a distance of a. I don't know what number that is, but I know it's the same number every time, right? All right, what's my distance from here to here? From A to C. A again, don't, these are points. Do not use the capital letter. That is the name of a point. You have to use what's in the parentheses. Those are x and y values. Some of you have said multiple times, or multiple different people have said the name of a point. The name of a point is just a name. That's not a number, not a variable. It's the name of the point. If it's a capital letter, do not use it. It's just naming the point. It's just telling, it's helping me tell you which point I'm talking about. The numbers you're using are in the parentheses. So to go from here to here is also a. If I have the same distance between two lines, they're parallel. Have to. Not going to go into a big proof about it, but they have to be parallel. So how far am I going to get from point C? Again, this is a point. Point C to point E. I'm going A again, right? 2a is the x, subtract a. Well, 2a subtract a is a. So I'm going A again. So if I go A again, lines are parallel. So I'm not going to make you prove that. I'm not even going to put anything on the quiz about it. I would definitely say you could see something like that on the midterm. Knowing what the district is, that they love conceptual stuff, things you can't just plug into a calculator. That is definitely a conceptual thing. So, again, you cannot exempt my midterm. So you will have to take it, and knowing it's 20% of your grade. That's one you can try to do on your own, the check problem. Complex, but the more you can figure out, even the more you struggle and try to figure out, better prepared you'll be for the easier ones. Practice problem. Not doing anything, although that was on quiz that I did one time. What would you be doing here? First thing you should, it's not technically on a coordinate plane, but it kind of is because you have x and y values. We could split it in half. What else could we do? Again, it's not on a coordinate plane, but it kind of is because you're being given x and y values. Anytime you're given x and y values, what can you do? Distance formula. That's what you need to think of when you see this. Technically, they're longitude and latitude, but that's kind of like distance. Like it literally is the distance on the world. Like that's what longitude and latitude are. They're x and y coordinates, basically. That's how everything is mapped. All the GPS stuff you use on your phone, it's mapped with those longitude and latitude numbers. Not gonna do that. There. Okay, so now we're fine. So as far as the problems for this, I think we're just gonna say 5 through 8. Actually, let's say I'm not super worried about you proving. Just read through. We'll say 5 through 9. So page 331, 5 through 9. So that'll be everything that is on the quiz, along with like some of the types of problems that we use to solve. Did I give you problems for the last? Yeah. No, I don't think I did. Let me go back and see if there's some problems I need to add in there from the lesson we did last class. Oh. Oh no, right. There wasn't. I looked at the problems for right triangles and it was mostly about proofs, which I'm not gonna have you do any real proof stuff. Even I'm not even gonna have you tell me if things are congruent, using like hypotenuse leg and all those other things. So if I give you something about right triangles, it'll be more along the lines of you just understanding a right triangle. A squared, B squared, C squared. One angle's 90, the other two have to add up to 90. So there may, I mean, there must be another, I know there were right triangle problems that we covered last year. Maybe there's another lesson or something where it comes back into play. Because there were none of that. That was all just about proving right triangles. But I might give you like one problem where you have to do an A squared B, understand like how to use A squared, B squared, C squared, or something like that. Other than that, it'll be those other problems I just gave you. So make sure you though, again, you're not getting any practice problems. Make sure you understand right triangle, A squared, B squared, C squared. All right, so you can practice, not as much time as I wanted you to have. You can practice for a couple minutes. Well, they have probably staying up until 3 or 4 a.m. every night, and then all of a sudden having to get back up. You missed the last bit. So I feel like there's conspiracy, and just. I know you did one retake of makeup or something. I don't know if that was it. So I'm not done with all the retakes and makeup quizzes. I thought I was, but then realized when I got here, I left some here at school. So I graded everything I took home, and I apparently accidentally left some here at school. So I'll get those graded as soon as I can. The new quiz, though, the one you took right before break, that one is in. Oh, the deadline for transformations is this Friday. So if you need tutoring on that, you got a 40 or below. Remember, you got to do that first. Yeah, it was pretty similar. Yeah. Although if you got a 45-minute, not even 45 minutes, they're able to make it a little longer. Yeah. Well, this is one of my quieter classes. Like first period is still like you don't come into my first period, but I mean, first thing every morning, they are the loudest, like most social. They work too, so I let them be more social than I probably should because it's loud. Sometimes it just is loud. Like, and I like catch myself like yelling over them as they're talking to each other and doing stuff. But again, they keep up. Their grades are always good. Their test scores are always good. So I let them get away with it as long as they keep those up. But yeah, it is. I'm like, how can teenagers be that awake and active at, 7 a.m. But they are. That's the only, well, actually, fifth period can get a little loud. You've been in the
Yeah,
fifth period. They can get a little loud. They don't work. That's the difference. What was I just, oh, did I do attendance? I did attendance. I did